All right, we're back for day 9 of Advent of Code. Taking a shot at this one at a little bit different time of the day because staying up till 1 a.m. working on these things is, well, it's killing me a little bit. So, we're going to try to blast through this. I've given myself a couple hours to get through this, and here we go. So, let's dive in. It's day 9. It's a little too zoomed in there. All right, so this one's called Disk Fragmenter. Another push of the button leaves you in the familiar hallways of some friendly amphipods. Good thing you each somehow got your own personal mini submarine. The historians jet away in search of the chief, mostly by driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting. Okay, so he's in his submarine and he's worried about free space for his files. But his program isn't working. You offer to help. He shows you the disk map, your puzzle input he's already generated. For example, 2 3 3 3 1 3 3 1 2 1 4 1 4 1 3 1 4 0 2. The disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map, like 1, 2, 3, 4, 5, would represent a 1 block file, 2 blocks of free space, and a 3 block file, 4 blocks of free space, and then a 5 block file. A disk map like 90909 would represent 3 9-block files in a row with no free space between them. Each file on disk also has an ID number based on the order of the files as they appear before they are rearranged. So we're going to have to rearrange some shit. Starting with ID 0, so we start counting from 0. So the disk map 1, 2, 3, 4, 5 has 3 files. A 1 block file with ID 0, a 3 block file with ID 1, and a 5 block file with ID 2. Using 1 character for each block, where digits are the file ID and periods is free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. The first example above represents these individual blocks. Okay. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block for the disk map 1, 2, 3, 4. The process looks like this. So free space, move the 2. Free space, move the 2. There's a file here, so I can't do anything. Or there's a file here, so I can't do anything. So we got to go here. Then here. Then here. And then finally we're done. And this is for our actual example. It's a lot more. Okay, so once we get them here, so we basically have 3 steps to translate. So we need to translate this into this. So that's the first thing. Then the second thing is we need to translate this into this. And then the final step of this file compacting process is to update the file system checksum to calculate the checksum. Add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is position 0. If a block contains free space, skip it instead. Continuing the first example, the first few blocks' position multiplied by its file ID are 0 times 0, because the file ID is 0 and it's in the 0th position. This is file ID 0 in the first position, so that's still 0. This is file ID 9 in the second position. Okay, so we go on, basically just whatever the index is here times the value that's there, and then sum those up. All right. Let's get into this. Let's get our, I don't think I got my input set up yet. Yeah, so I need to get my input. Ooh. That's a long piece of text. That is one single line in numbers right there. Okay. Let's go into our disk fragmenter program and let's start thinking about this. So instead of having, I'm going to try a little bit different approach. So instead of having my different approach is going to be, instead of having a parser, I'm going to have a disk map. That disk map is going to take in my input, and then my disk map is going to do the work. So we're going to call this class disk map, and it's going to take a string, which actually it's not really the input. What is this? What do they call this? The disk map uses a dense format. So we're going to call this dense format. And we'll go ahead and set that to private read-only string called dense format for now. And I don't know, I might not need that, but that's where we're going to start. And then we're going to have another thing that's called private read-only private list only. I think this is actually going to be, so the way they represent this is they're representing this with dots. And I think what I'm going to do is, I'm actually, just so that I can make it a little easier on myself, I'm just going to deal with numbers. And so I'm going to represent a dot as a -1. And then I'm going to have a list of ints that I'm going to call, what am I going to call it? I'm going to call it dense format, and I'm going to call it, it's still a file map. That's still what this is. Or still disk map, but there's the dense description of it, and then there's this expanded version. So I'm going to call this the expanded format, and then I'm going to have a method that I call to set this called get expanded format, and that's going to take the dense format. And actually, I don't think I actually need that, because I'm just going to be working from this expanded format. This is going to be a private, I think it can be static. It's going to return a list of ints, and it's called a get expanded format. And we're going to call this, what are we going to call this? String dense format. And actually, instead of this being a constructor, I'm actually going to, so I actually going to do, I'm actually going to do a private disk map that takes a string, which is the dense format. This is purely just ergonomics. Expanded format equals get expanded format. And the reason I'm going to do that is so that I can then have I'm going to have a public static that returns a disk map, and it's going to be called from dense format turn new disk map. Okay, and then, so we need to parse this. So we're going to say for each var, right now they're just characters. For each character in dense format. I'm just gonna call these parameters dense format. Expression. And I could do it through a constructor. I just kind of think I like this of saying var map equals disk map dot from, and then the input. And this needs to be, instead of read all lines, it needs to be read text. Yeah, I like that. Yep. Yep. Okay, and we're gonna do 2 at a time here. So instead of for each, we're just gonna do a simple for loop, and we're gonna say character index dense format dot length, and then we're gonna say var var file. What do I want to call this? The first number is an actual file. So we'll say var file length equals character index I. Nope. Dense format, character index I, and then var free space is going to equal dense format character index plus 1, which means we actually need to stop this loop early 1. And these are still going to be characters. I need to get them to be ints, but some of them aren't ints. Are they? No, all these are ints. So we can say parse int Oh, not not parse. Int. I'm not writing JavaScript. It's int dot parse. And int dot parse. All to string on that. Yeah. Bar expanded format equals new list of ints. And now I can return that down here. That. And then I can say first thing we have to do is we want to add the file length. So it will be expanded format dot add range, and then we'll say we basically just want to create so we'll say enumerable dot repeat, and the thing I want to repeat is what? It needs to be the file length. That's how many times it's going to repeat. And then I need the characters, which, excuse me. I need the characters that I want to repeat, or the number, I guess, in this case, that I want to repeat, which I don't have the number yet. Right? I don't have the number yet. So we basically need to keep track of a incrementer. So var file ID. So it starts at 0. So yes, and then could I use the character index to do this? No, I can't. Can I? Well, if I increment this by 2 at the time, could I? Do I need to have a separate variable for that? I don't think I do. So I think instead of doing this right here, increment it by 2, and then that would still, yeah. So we'll just take 2 at a time. We'll jump. So yes, so I can use this index. It'll be 0. And the next time it'll be 2. Oh, no, I can't, because the next time it'll be 2 and I want the file to be 1. So I do need a separate file ID here. So we'll say expanded format.add, and this will be the free space. I'm going to call this free space length. And that's going to be represented by -1 in my case. So you can just think of the -1s as the periods. And the only reason I'm using -1 set of periods is because I'm going to have a list of numbers, and it's just easier to have a contiguous list of numbers than have mix numbers and characters and work with strings. So I'll just work with that data type. And then the last thing I need to do is I need to increment file ID. And then we'll come back there. Okay, so that should return the expanded format. So let's add a test for this. Should have added the test ahead of time, but we'll do map tests, or no, disk map tests. That. Gonna be a test method, public async task, map constructed. Dense when it should var only. Oh no, this actually can be a const, private const string. Let's just start with the real simple one here. Equals this map dot from dense format. There's my example input. Wait. Type. And that's kind of a simple test, but I more wanted theirs just to debug it really quick. To just, because I'm not going to, right now, I'm not going to expose this expanded format. So let me build this. I'm going to debug it because I just want to see if this gives me the, I just want to see if this gives me this right here. That's what I'm looking for. Index was outside the bounds of the array. Was it because it's odd? Yeah, so I'm jumping over. So I need to add some sort of check there for that case where it is odd. So if it's odd, it always ends in a file block. right? Because we're taking 2, so this would be file block, free space, file block, free space, file block. So it's really the free space that could possibly not. So we'll say we're always going to do the file. Our free space index equals this. And we'll say if free space index is less than its format.length, then we're safe to do this. But if it's greater, yeah, if it's less than that, we're safe to do this. Now we'll try to debug it. It's our map. So we should have 0, negative, 2 negative 1s, 3 1s, 4 negative 1s, and then 5 2s. Nice. Okay, so we're on the right path here. Stop. Or no, continue. That should pass. Okay, now what we want to do is what do they call this process? Move. The antipod would like to move file blocks at one time. So what we need to do now is we need to compact, right? We need to compact the and I think this is where I'm going to have another private constructor that's overloaded that takes an expanded format. And I'm going to say private dismap. It takes a list of int, and this is the expanded format already. And it just sets the expanded to expanded. That. And then I'm going to have a method that's called public. It's going to return a new disk map, and it's going to be called compact disk. Just return new for now. Okay. So what we'll do is we'll say var compacted format equals this map's expanded format. We'll make a copy of it so we don't mutate that the current one. And we'll say we're going to give you back this. So we can do another test method. Public async task compact and call or compact disk. And call it should new disk which in this case, the only thing I want to do is I want to say var map var compacted map equals map dot compact disk await assert dot that compacted map is not equal to they shouldn't be the same. They shouldn't be a reference to the same object is basically what I'm checking here, because again, I'm still not exposing this expanded format publicly at the moment, so I can't really check it. But I can use this test to one, make sure that I'm not mutating the original disk, and also I can, you know, actually I could even make this. If I didn't want people mutating this, I could actually do like I could do like I read only, couldn't I? And that prevents you from doing things like adding. So that's probably a better option. At least that's a safer option while I'm working in the within the class. I don't know if that really matters for solving this problem, but whatever. Okay, so this should now have a test. Build it. I feel like I'm making better time. So here we go. Famous last words. Yep, so those aren't the same, but I haven't actually done any work on that list. So this is where I'm going to do the actual compacting of it. And the way we're going to compact it is we're going to say we're going to loop over. And it looks like we start from the end, right? So one at a time from the end of the disk. Okay, so I think we need to use a for loop. We'll start at the end. I guess it doesn't really matter. We could do that. We could say expanded format. Length. Dot count or dot length? Dot count. And we can say this is the one we want to mutate. Right now, it's going to look like this guy. So this is the thing we're trying to move. This is where we're trying to move it to. So I'm going to call these positions var placement equals possible placement equals so compacted format I. So that's we're starting at the left, and then var block to be placed equals compacted format, and then that's going to be compacted format dot length or count minus 1 minus I, or 1, I guess we could just say 1 plus I. Okay, so that's not going to work though totally, because that's not going to work totally because I don't always, like in this case, right? I'm trying to move 2. 0, we have to continue, right? So I moves to the next, but we don't want to move from here. We want to stay here. So we have to increment these indexes independent of one another. Yeah, we sort of need the same idea that we have here with the file ID, where this index and this index, they sort of have to be independent of one another. So I'm going to call this var block to be moved index. And that starts at the end of the line. So I'm going to call that this. There's probably better names for these indexes, but yeah. And we should probably give this I a better name, shouldn't we? Let's call this placement, or possible placement index. Oh, can it really? Well, let's finish writing and then maybe we'll convert it. So the first thing we need to do is we need to say if possible placement index does not equal, or if it does equal is -1, we can just continue, because that's not a thing. If it is -1, we can swap these things, right? So if it is -1, we can just swap them. So we can say compact format, possible placement index equals the block to be placed, and then the compact format block to be moved index can be overwritten with a -1 because now it's free space. So that means we're technically here. And then we can move that block to be index position by 1 because we've successfully swapped them. This guy. Yeah, I think that should give us back what we're looking for. So let's run this test again. And let's put a breakpoint in there. Debug. Oh, I ran over. Where did I run over at? Line 248. Oh yeah, we need some way to know. Should it be less than? I mean, I basically just need to add a check, right? That says there's also a case where if we have a uneven, there's also a case where we end up in the middle, and then we would be checking the same spot, or could be checking the same spot. Yeah, so that's at the top here. If block to be moved indexes is less than 0, we also want to continue, or maybe we want to just break at that point. Oh, that's because that. Okay. Yep. Okay. I see what I did there. Because I'm incrementing it, and I should be decrementing it. Now let's try again. Yeah. So compacted map. That's not quite what I was looking for. Oh, shoot. Well, there's a reason for that. That's because if it is -1, I'm continuing. What I want to say is if it's not -1, I want to continue. Zero, two, two, one. Bunch of negatives. Two, two. Yeah, that's still not right. So where have I gone wrong? If it's not -1, I'm going to continue because I can't place it. Then when I come back through, I should be checking here. That should be -1. So I should have 2. Let's step through this. Let's step through this loop. So we're starting at 0, and we're starting at 14. So we step over. So possible placement is 0. That is not -1. So we continue. Yep. What? Why did... Should have gone back up to here. So we're looking at 2 and 0. Those can't be flipped. We're looking at 2 and -1. Those can be flipped, so they should. We're looking at 2 and -1, so those can be flipped, so they should. Possible placement's 1, so we should move on. We should do that 3 times. Yep. Now we're looking at 2 again. Yeah, we're looking at 2 again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, we're looking at the right 2. Those should get switched. Hold on. Why is possible placement index 6? Because I'm incrementing the read pointer each time? Is that why? That doesn't seem right. Yeah, so No, that's right, right? Yeah, 2, replace at 2. What am I talking about? Yeah, that's right. Then we should go through again. It's -1. And it's 2. So we should place that 2, 2, 2. Okay. Then what are we doing? Oh, now we're -1, -1. So it's not just if the possible placement's not -1, or block to be placed, it's not -1, or is -1, because then that's free space. We don't need to move it. I tell you what, having a debugger, God, this, I don't know how people would do this, just printing stuff to the console. There we go. That's what we were looking for. Okay, fantastic. So let's stop that, or actually just continue. And then the last thing we need to do is we need to add a method here for, we need to add a public method for calculating the checksum. So public int calculate checksum. And what that's going to do is just return an int, return 0 for now. And then we can say task public async task compact disk. When called, it should return expected value. Not task, test. And then we can actually say, we can actually just do a nice result, and that's going to be dismap.fromDiskFormat example input dot compact the disk dot calculate the checksum. And then we can say await assert dot that result dot is equal to 0. Nope, it shouldn't be 0. It should be 19. Would be, sorry, I thought I heard something. What should it be? So based on the logic, it's basically that index times the value at that index is what the checksum should be. So if the expanded format looks like this, then it's 0 times 0. It's 0. Yeah, I can do this. Let's see. It's going to be var total starts at 0. Then we're going to say for each. Actually, we're also going to say var no free space equals expanded format dot where I is not -1 dot 2. Actually, we don't need to list it. We can just say, so for, we're going to say for file blocks. That's all we care about. Block. And we'll actually do select, because we want the block, but we also want the index. Just return those back. And we'll say block index. And then the total is going to equal what's it going to equal? It's going to equal block times index. This is actually not the, it's actually the file ID. I cannot resolve symbol file block. File blocks is a variable, but it's used like a type. Oh, I'm missing a parentheses. I was like, I know I've done this 100 times before. And then we can return the total. So if I were to do this calculation manually, I would have 0 times 0. Then I'd have 2 times 1, 2 times 2, 1 times 3, 1 times 4, 1 times 5, 2 times 2, 2, but not 2 times 2, 2 times 6, 2 times 7, and then 2 times 8. So the right side is all the indexes, and the left side is all the file IDs at that index. So real quick, get the old trusty calculator out here. So this is going to equal 0, 0, that's 2, that's 4, that's 3. See, this is why you memorize your times tables growing up, so you can solve advent of code challenges. All had a purpose. So then that's going to be 2, or 0 plus 2 plus 4 plus 3 plus 4 plus 5 plus 12 plus 14 plus 16 to 60. So this should give us 60. Okay, close tab. Build this. We should get a new test show up here. But it shouldn't be called compact disk. It should be called calculate checksum. Refresh the test list there. Tab. Nice. Okay. And then let's give it our actual part 1. Let's calculate checksum and call sample input. Good. Value. I'm just going to rename this to be test input, and I'm going to have a new one. And this can also be sample input equals the big long list of numbers. Sample, and they're expecting this to be 1928. Build. We found 230. Okay, well, let's look at our map and see where we've gone wrong. 30. Stop. Stop. We'll put that here. Debug. Zero 9 8 1 1 1 8 8 8. That's right. 2. Okay, so somehow we got off 2 1 1 8 8 8, which was good. We should have a 2. But somehow we got off here. Oh, I think I know what's happened. Okay, there's a problem with when I'm building this map and I'm compacting the disk. And what's that problem? The problem, I think, is Well, let's just see. I think I know what the problem is, but let's see if I can confirm. So basically need to get to this point. So we're just gonna say here. 9, 8, 8, 8. We're looking at 2. The block to be placed is -1. Okay. What is block index right here? Block to be moved index is 35. Yep. Okay. Now we should be at block to be moved index still 35, still -1. Because basically at this point now, we're going to move off of that free space. Move off of the free space, move off of the free space. Now the possible placement is 3. That's 4. And then it just gets all out of whack, don't it? Because if the block is free space, so if the possible placement is free space and the block is free space, we don't want to move this. We just want to move the right. I think what will make this work is if I say am I still debugging? Can we stop that? I think yeah, if block is negative, if basically I'm going to say if these I think we want to say if they're equal, don't we? If possible placement is, or if possible placement is -1, and the block to be placed is -1, why is it always false? Because that makes it return earlier. Yeah, so if block to be placed is -1, we want to continue, but we don't want that index. We don't want this index to change. So I think I could do something hacky and say possible placement index and decrement it, and then it'll basically stay in the same spot. Let me run that. Run unit test. Or did I just create an infinite loop? I don't know, I thought that would work. We're at 35, that's what we're looking at, 35. And we're looking at this one, 12. So my thinking was that oh, and we also need to, okay, so we also need to increment the block to be moved index. That seems really hacky. Okay, so what did we did something. Let's debug this. I can feel that I'm close. So expanded format. What's this look like? 2.7 -1. If we get down here, then we know the possible placement is -1. So if the possible placement is -1 and the block to be placed is -1, okay. Still not seeing it in my mind. We should be at block to be placed is -1. Oh, no. Yeah, basically want to hit there. But the first time we enter here is on this one. So or 7.333. What's the block to be moved index is 31. Okay. Keeps jumping on me. Nine, 8. Seven, 3, 3, 3. Negative 1, 4, 4. Okay. So this is negative 1. This is 3. So the possible placement isn't 3, but this is. So we're here. We're checking this case right here. Block to be placed is negative 1. Okay. This is negative 1 and this is negative 1. What's the index? 31. Negative 1, negative 1. We're not moving from here. We're still here. Now we're at 30 and 18. 30 and 18. This should swap. Right? Yeah. Okay. Block to be placed is 6. Placement index is 1, so it should switch. That's 6. Then we should be all 5s. And the next one should be, so it should just be 5, 6, 6. Just need to shift these two down. Let's make sure. This really shouldn't move anymore. But it is. It just shifted the 6 around again. And it shifted it around again. So do I want to stop shifting when those indexes are on the same spot? Yeah, let's try that. So if block to be moved index equals possible placement index, want to break out of there. I think I can do this without doing a for loop. Yeah. I think this would be actually, I think this might be easier to deal with in a while loop. Okay. Now we can say var result dot compacted disk dot calculate checksum. The checksum of the calculate or the compacted disk is all right. Let's give this a run. Project. This is day 9. This is called disk fragmenter, and then we're going to give it day 9's input. Well, that's not right. Is this a big number? Do I need to be using longs? Well, don't I get an exception if does C# throw exception if int max is reached? I think it does. Oh no, okay, so it's not an overflow, it just goes, it wraps around. Yeah, so I think that's the problem. I think I need to say I think when I calculate this checksum, where is it? I think I need to be using a long. Do that. Try again. Yes. I finished today's part 1 in less than 2 hours, which I've not broken that this advent of code yet. Okay, let's see how complicated part 2 is, because I only gave myself a certain amount of time to do this in, so we're gonna have to see if I can. I might have to split this up into 2 different sessions. Let's see, mark HTML to markdown. There. Copy that. Back to our problem. Paste this guy in here. We will. I wonder if maybe I am doing better because it's not 12:30 in the morning when I'm trying to solve this thing. Okay, So we got our problem saved. Let's go back and read it. Upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space. Blocks that could fit the file to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. The first example from above now proceeds differently. So you start here. 9 can be moved, so it moves. This cannot be moved, so it doesn't move. This can be moved, so it moves. Interesting. Okay. What's interesting about this is now it almost makes sense to have a different format. Now it actually, to me, it makes more sense to have these into a list of blocks, right? So you'd have a block here, block here, block here. So you have a list of blocks, and those blocks essentially correspond to this. And then you would just basically compare. You'd start at the end of the list and say, okay, my block over here is length 2. Is there a free space that I can move it to? It's almost like you have two separate lists. You have a list of blocks that are free spaces and a list of blocks that are file blocks, file IDs. And then you start at one end of the list. You say, okay, here's my 99. Does the first free space accept that? No. Okay. Does the second free space accept that? No. Does the third free space accept that? Or no, does the first free space accept that? Yes, it does. Okay. Put 29 into those spaces. I'm going to rename this. Or no, I'm going to keep that the same, and then I'm just going to need a new method that's called public. It's going to return a disk map, call it compact disk without fragmentation. And it's going to, at the end of the day, it's going to return a new disk map like that. For compacted format equals expanding format to list. And I also need to update my checksum. to not do this. My test still passes. Test. Okay, so that still works. So now what do I need to do here? How do I need to think about this? It's really just a bunch of pointers. I mean, the right. So you'd basically have you'd have var file block start index, and that's going to be compacted format.count minus dot count minus 1. Excuse me. And then you're also going to have var free space free block start index. And that's going to be compacted format dot index of -1. That should return me the first index. Searches for the specified returns the 0 base index of the first occurrence. So that would give me this. So how would I get this guy? So I'm going to say var file block end index equals compact format plus 1 while compacted format yeah, I don't know how about this. This seems not ideal. No, while the index equals this, while the end index equals the start index, or the characters, then we're gonna keep incrementing the end index. So my idea here is we should start at 9. We should increment this by 1, which should put us here, in which case our file block will be this, which should be, what is that? That's 11, or whatever the count minus 1. So let's see. Dismap. Compact disk without fragmentation. Yeah, so I want to debug this. So build, close tab, build this. Where am I at on time? I can go a little longer. Yeah, this is gonna be here. Back. block. Oh. Shouldn't be adding, I should be minusing. Var file block in. I don't understand. It says 13 and 14. So the file block should go to 10. I screwed up the. This should be minus. Keep screwing up the math. Okay, debug. Yeah, 9 and 14. So okay, stop. Then I'm going to say kind of the same thing here where I say var free block. I'm actually going to start them the same place. Free block and index equals kind of thing. In this case, though, I'm going to plus. The file free block is at 1. Oh, whoops. Need to replace these down here. Yeah, I just created infinite loop. Yeah, so 3 is where it ends. Yeah, okay, so 14 minus 9 is going to give me the length, which is 14 minus 9 is 5. 1, 2, 3, 4, 5. So that won't work because this is only 2 length. So we say bar 3 block length equals free block end index minus free block start index. Our file block length equals file block end minus file block start. Because we're going from the end, we actually will do this. That way it's 14 minus 9. Block that. Debug. This should be 5 and 2. Yep. Okay. So that means if I mean, the other way I could do this too is I could just say, can I move it? Can I move it? Can I move it? And if I run out of spots to be able to place it, like if I have to do a fragmentation, then I just start over. Is that easier? Because I already have this I already have this, which is compact disk. So if I'm trying to place something into a space that's the same as the last thing I placed, and I can't place it, then I know it's going to be fragmented. There's probably a couple different ways to solve this. I don't care for the way I'm doing it because it feels like I'm keeping track of a lot of indexes, and that seems error prone. Okay, so if free block length is less than file block length, then we are going to need to return for now. Yeah, I don't know. We're going to need to do something. We need to exit a loop, because this is all going to be in a loop too. This finds the end of the. We find the end of the block. We find the end of. We find the end of the free space. We see if they're what their lengths are. We see if the free length can consume the file greater than or equal to. Then we know we can move file into free space. And I think what this is going to be is it's going to be while file block index is greater than 0 and file block and free block index is less than compacted format dot count minus 1. Okay, so let's handle the case where this is great. Free block is less than. If the free block is less than, then we don't want to do anything with the file blocks. We want to keep the file blocks indexes where they're at. We want to keep them where they're at. Yeah, there's got to be a better way to do this, because basically then if we do this, okay, I think I'm going to have to pause because I can't spend unlimited hours during the day working on this. So I think I'm going to pause here. Part 1 is solved, and I'll come back for part 2 later today. Yeah, come back for part 2 later today, because there's got to be a way to do this without because if we're just looking at like our example up here, like our smaller example here, I'll get this, and then if I find that this can't fit the file block, I want to continue, but I don't want to come back through here Well, that's a good question. If I do come back up here, they're not going to equal each other. And they're not going to... Okay. Okay, hold on. I'm not going to... Hold on. I'm not going to pause yet. So... basically, if free block length is less than file block length, what I want to do is I want to set free block start index equal to free block end index, which makes them equal again, which means when I come back up here, I'm just going to find the next free block. So continue. Yeah, okay. I think this is now this is making sense. So when I get here, obviously the length, where's the length? 2 verse 5. So we're going to hit this. We're going to step over and we're going to set the free block, which is 3, to this. So now they're going to be 3 and 3. And then when I come back here again, what's the free block length is 3 and 6. So that's 3. Is that right? 0. No, it should be 4. Should be 3. 3. Or this, it says 3. Which is here. 3 to 6. Okay, so that's not how I'm going to reset the start. To reset the start, I'm going to do this. But I need to say searches for the specified object, returns a zero-based index of the first occurrence, the zero-based starting index of the search. So I want to start at the current free block end index. Set the free block end index to the free block start index. Debug. The first time I hit this, the length should be the length of the free block. Oh, well, I definitely have an error. So, yeah. So this should be 5 and 3. Then I should come through, hit it again. 4 to 10, which is a length of 6. No. 6 to 10, which is a length of 4, which is correct. The file block length, though, is still 5. So I can't move it. So then I'm going to step over. What do these become? These become -1 because index of returns -1. in which case reblock less than. I just need to have a condition here that's basically, or I guess I could put it here, that says and reblock end index is not negative. Okay, so run. Yeah. Then, so if it can't move this guy, it should try to move this guy. So then else, keep the freeze block the same. We're still looking at the same piece of or no, this is the case where the block can be moved. Yeah. Basically need another loop. A lot of loops here. I'm sure there's some, again, I'm sure there's always just some elegant way. While file block end index is greater than 0. And then copy. So we find the file, we find our first file block. Then we're going to go in here. We're going to find our free block. We're then going to say if free block because at this point what we can do is we can do the moving. We'd say like for each bar I equals 0. No, not for each, just a for I less than 3 or and I equals 0 j free block start index I is less than 3 file block j plus because what we do then is we say okay, compacted input of I say bar file ID to move equals active format J bar place to move need to move and then compacted format J becomes -1. And then the moving's done, so we moved that block, that file. Now the file block's been moved, so we're gonna break. But when we break, we're going to move the end of the file block. We're going to move the start of the file block to the end. So we'll say file block start index, file block end index, file block start index equals file block end index, like that. And then there's one other thing we need to do. Because let's say I can move this, right? So what I did was I moved this index to this index. But if this is a free space, so while this equals this, we basically don't want it to well, we can do that by saying compacted format dot or search. We basically want to find the first occurrence from the right that isn't a -1. Yeah, so C# index of not -1, not C# find last element yeah, I mean, that's what I want to do is I want to just basically say, hey, give me the first index of or searches an element, searches for an element that matches the conditions and returns the first occurrence. Find last index. Yeah, that's what I'm looking for. So I say find last index. And in this case, I'm going to start from I'm just going to say where I is not -1. But then down below here, when I reset it, it's actually going to be file. It's actually going to be compacted format dot find last index, but we need to give it the start index. And then in this case, the start index is going to be the file block, end index, and then, but the thing is still the same. I is not -1. And then file block end index becomes file block start index. And anytime the comes greater than 0, no, not greater than 0, because we're moving down. So it can be greater than -1. God, this is so messy. Return this. So with the input we've given it so far, none of these can be moved. This can't be shifted to the left. This can't be shifted here. And this can't be shifted to the left here. So it should just give me back that, which I think it's doing. When called with test input. When called now example input with test input. Now what I want to test is when called with example input. I want to debug this. I know I said I was going to take a break, but then it felt like, oh, I think I'm onto something, so I didn't want to walk away when I felt like that. So let's see. With example, yeah, with example. So debug this. Oh, I think I know what I did. I created an infinite loop because and I'm compacting the disk without fragmentation, and I do all this. That wasn't even with the example. That was with the example. Why does this cause an infinite loop? Otherwise, this should break. Continue. Continue. Free block length is 3. File block length is 2. Oh, I don't want to debug that one. Tab, I want to debug this one. Yeah, so let's see. It's -1. We should go up here. Let's see. File, block, index. We're still there. Oh, actually, stop. Stop this. So this, I actually don't need this here. I need this here. And the reason for that is we're iterating through all the file blocks. And so at this point, we've checked a particular file block against all the free blocks. So this should not get stuck in a loop. While file block index is okay, let's debug this now. Here, ship this twice. Now we should go back up. File block dart index. Yeah, because we found the next one. So then that should go to 2. Right? Yeah. Let's see. Four, 3, 2. Zero. They're equal. Yeah, so that's an interesting. It walks off the edge. Still valid. But we really shouldn't be able to decrement that. So we should say if file block end index is -1 break. Oh, where am I? So we also have to restart this, don't we? To reset these two. But we need to reset them to whatever they were at the very beginning. Let's see. It's still gonna break. Still gonna break because debug this. What the heck? We're stuck here. We're stuck here because why? We're stuck here because 6 and 10. 6 and 10 is 4. The file block length is 3. Shouldn't it be hitting that? No, the file block length is. File block length is 3. Well, I did in fact run out of time, so file block length is 3. And it says the free block length is 4. Oh, yes. But yeah, okay, yep. Let's see, stop. But it needs to be after the file block in index. When I restart it. Okay, now. Oh, no. It's actually a check inside this loop that says the free block length has to be less than, or if the free block length is less than the file block length, or the free block start index. So like this guy can't move here. 1111 can't move to the right. So if the start index of the free block is greater than the end index, the file, the free block start index is greater than the file block end index, then we'll also continue. Okay, I do have to pause. I have a hard stop now. So I'm going to come back to this one. Let's see, I got part 2 done in like an hour and 20 minutes, and now I'm sitting at 2:30 for this part 2. But I'm going to pause here. I'll be back later today to finish off part 2. Yeah, so I'll see you in a bit. We're back. We're picking up where we left off. We're trying to finish solving part 2. And the last thing that was happening was basically I need to be accounting for. So basically, the last problem was that I was trying to shift blocks like this to the right, which I shouldn't be doing. So I need to add a check up here. That's basically going to make sure that it's basically going to make sure that the free block index end is less than the free or the file it's less than the file block index. So since we're going this way, the end of the free block needs to come before the end of the file block. Yeah, and then I think that will get me down here. So back to my test. Let's see, without fragmentation. Yeah, this is the one we want to be debugging. So we should get down here now. And if we don't get down here, then we have a problem. Okay, we're in a loop. Do we hit here? Okay, so we are hitting the loop, which is what I would expect. So what happens when we... Oh. So these actually need to be flipped. Yeah, because I think this is always going to be 41, 39. So the start, in case of the file block, because we're coming from the right end, the file block start is never going to be less than the file block end. So we actually need to flip these. So stop that. We need to flip these. This should be start. And then this should also go in the other direction. So instead of incrementing J, we should be decrementing J. Because really what we want to do is we want to go from start to end. So we want to move down an index. Okay, so now we should actually get into here. So debug. Yeah. So what should happen is these two -1s should turn into 9s. We should be able to take these 9s and stick them here. So let's see. Well, that's an 8. That's not what I want. So the 8 and this -1 switched places. Oh. Oh. Well, the reason for that is because we're in this nested loop. And I don't think we need to be. So right now what's happening is I'm trying to go over, so the free block is 3, so this loop's going to iterate 3 times, but every time that loop iterates, this inner loop's going to iterate twice. And so we're essentially going to end up trying to place the file, we're going to end up placing the file ID we want to move into the same free block space again and again. That's just an outright mistake. This actually just needs to be a separate for loop. And I'm actually going to put that one. No, I want to do that. So yeah, so we take this and move it here. Move it here. And we don't need this anymore. Or I don't think we do. Let's just move that to the loop down below. So okay, so this is what this is going to do is it's basically just going to for every file block, for every one of these for one of these file blocks, we're just going to we're going to reset it to a free space because we're moving those file blocks. But that needs to happen after this one. Because we don't want to set those file blocks to 0 and then not be able to get the ID that was there. So we want to move the ID, then set it. So to get the ID that we want to move, all we really have to do is we just have to say compact format and then file block start index. Because all the file IDs are the same in the block, just based on the requirements or of how the format's laid out. So we can just grab it that way and we'll stick it there. However, remember that in these cases, the free block can be longer than the file block. That's what we're checking for up here. So we don't want to do this. We don't want to do this loop the same. We don't want to do this loop the same number of lengths as the we don't want to loop over this the same number of times as the free block's length. Like in this case, we only want to do it twice. So we need to get that delta, right? So the var block length delta, which is going to equal the free block length minus the file block. And then we want to subtract that off the end of here. Right? So think about this. Right now, the free block length is 3. So we would do this loop 3 times. Going from the start to the end, we would do 3 loops. And we want this incrementer to increment the actual index, the actual start index, because those are the specific places we want to do the replacements. But we actually only want to go as long as the file block is. So what we'll do is we'll calculate the difference, which in some cases this will be 0. But in cases where it isn't 0 like this is going to be 1. So we'll subtract 1 from this free block index. And so then we'll only place it in 2 of the 3 free spots. And then for the file block index, we can just reset all those because we know we're moving all of them. Otherwise, we wouldn't be in this part of the loop. Okay, so now let's debug and set a breakpoint there and see if this works. So yeah, you can change. So the first time through, this should go. These two -1s should go to 9. That's not good. It just broke. Where did it break? Um, what? Okay, so we missed something here. File block end index. So let's debug this. This is 39. This is 41. Crashes. Must be non-negative and less than the size. I think the number's too big. Let's see, file block end index is no, file block end index 39. File block start index is 41. Yeah, why is this throwing? One, 39, 38, 37, 36. So is it hitting? Okay, so we are replacing things. See, we got 9, 9. But these don't look like they're being reset. Okay, it's 27. Yeah, it's replacing all of them. That's not right. Uh, oh, if we get down here and we've moved the files, right? So that's what we're doing right here. This is moving the file block. So if we've gotten down here, we need to break, and we need to go reset the file block and reset the free block, right? think that's I think that's what the problem is. Still, let's see. What am I doing wrong? Place the knives. Not. This is not what file block start index should be 41. We should have replaced that with a negative. Oh no, I messed up. I should flip these. We'll still go from start to end, and I should decrement, but now my condition should be while j is greater than end. Now this should work. Debug. There we go. So now this should be 9, 9, and this should be -1, -1. There we go. And then we come across again, the 7s get replaced. Now the 4s, 3s, and then I think that's it. Yep. Okay, so okay, I've gone out of the range again. This is why solutions that manipulate indexes like this and keep track of indexes and they're not good solutions because they're very error prone. So basically this is where I'm running into issues now, because I think this is actually, I think at some point this file block end index becomes -1. File block end index is 39, then it's 35, 31, 26, 21, 18, 14, 10. I think at some point it becomes negative. Yeah. So right now it's negative. So this is going to throw, which means if I get to this point and the file block end index is -1, we can just break. Because that means we've basically gone all the way to the end of the block. Yeah. Which I don't. I wonder if I could do this. Well, file blocks is not -1. So let's see if now we should get all the way here without us throwing any type of errors, which we did. Okay. And what's our format look like? This is what it should look like. 0, 0, 0, 0, 0, 9, 9, 1, 2, 1, 1, 1, 7, 7, 7, free space, 4, 4, 4, free space, 3, 3, 3, bunch of free spaces, 5, 5, 5, 5, free space, 6, 6, 6, 6, lots of free spaces, and then 8, 8, 8. Yep. Okay. That's it. Nice. Okay, so since now I'm confident that we're doing the compaction correct without fragmentation, what do I want to do? Close tab. Let's see if the checksum. Let's see if the checksum works now without. So we'll say basically have 2 of these. And the only difference is we're going to do without fragmentation. Without fragmentation. when called with test input and no fragmentation. No this one should be 2858. And I don't know what this one should be. So what this one should be is basically, since we can't move any of these, can't move any of them. It should be 0 times 0 equals, then it should be plus 0, 1, 2, 3, 1, 3, 4, 5, plus 3, plus 4, plus 5. And then, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be plus 20, plus 22, plus 26, plus 28. Is that right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I feel like I messed up somewhere. Get the handy dandy notepad out. Hey Cafe, can you stop? If you want to do that, you can do that in the guest bedroom. You don't need to do it out here. One plus 3 equals 3. 1 times 4 equals 4. 1 times 5 equals 5. And then this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 10 equals 20. 2 times 11 equals 22. 2 times 12 equals 24. 2 times 13 equals 26. 2 times 14 equals 28. So it's 0 plus 3 plus 4 plus 5 plus 20 plus 22 plus 24 plus 26 plus 28. Yeah, so 132. I did miss one the first time. 132. All right, let's go ahead and build this. We should have 2 new test cases to check here. And we want checksum. So run that one. Nice, that passes. And then this one. And that one passes. Okay, so now we should be ready to run this on our actual input, which is going to be .net run --project 09 disk fragmentation in day 9's input, and then part 2. Oh wait, I don't think I updated my main program. Yeah, so this is now going to be var map equals dismap.from input, and var compact map equals, this is where we decide part 2. If it's part 2, we're going to use map dot without fragmentation, and if it's not, then we're just going to use the normal method. And then the result is going to be that compacted disk. Oh, not disk, map. That. Okay, now we should be able to run this. I feel like that was pretty fast, 109 milliseconds. I wonder what other people's. Two. Nice. All right, so that was a little under 3 hours for that one, but I had to do it in 2 different sessions because I didn't have enough time earlier today. But that is good. I'm gonna go back to my map file here though, and I'm gonna add a method to get the actual private async task, get puzzle input, string, file.read all text, path combine, directory. Need to come up with some helper some helper libraries for some of these reusable yeah, get puzzle input, and then we're gonna add a test for these. So this, when called with puzzle input, so that will be var input equals wait get puzzle input. And then this value, what is this value? In part 1, no. Here. And all my tests should pass. Yes. Okay. Cool. Last thing to do is to update the README. What is that called? Disk.